Welcome to iOS Insights, the channel for iOS app development using SwiftUI and Swift. This tutorial is based on bar charts in SwiftUI, but data for the chart will be populated using JSON that shows how to use real-time data for a chart. This is the JSON data that we'll be using. This is a JSON array that includes two attributes or properties. The attributes are the keys. For example, order count is an attribute or key, and the value for order count is 2000. And another key or attribute is product type, and the actual products are electronics. So they call this key value pairs. So at the moment there's 1, 2, 3, 4, 5, 6. At the moment this JSON payload includes 6 records within the JSON array. So this is what we need to create. So to create this, the first thing you need to do is create a new file. So right click, hold down CTRL control key, left click, and then click on new file. And then you just scroll down and then you just select the empty file, click on next, and then you just give it the name, which is customer orders, and then click on create. And then after, when it's created, you will see you have a blank file and you need to enter this JSON payload within the file, which is all of this. Having entered the JSON payload within your customer orders file, we need to create a class, a data manager class that will get all of the JSON payload data. So let's do that now. So just left click within your project and hold down the CTRL key, the control key, and then select new file. And then just choose Swift file as a new file, then click on next. And call the actual file data manager. And now what we need to do is import SwiftUI. And now we need to create a codable struct. So that's struct product codable and then type in let product type string and let order count int. So order count and product type, they're the attributes or keys that are within the customer orders JSON file, which is here. Order count and product type they're all in the same case in lowercase. And then the next thing we need to do is create our data manager class. So it's public class data manager. And then we'll create a static method so we don't have to create an instance of the class to get to the actual method. The static function read JSON data product. So we'll be returning back an array of products to the calling routine. Var loaded products product equals product, equals empty array. So what we're doing there on line 20 is that we're creating an empty array of products. So we're just like initializing the array to have an array of products. And then what we need to do here is get the actual JSON payload, which is the customer orders.json file. Get that from the resources. So to load it into the actual memory for the application, we just type in if let file URL equals bundle.main.url for resources. Customer orders, and then the extension for the customer orders file is JSON. As you can see here, I think you can see here, see the order extension. The file extension is orders.orders. And then the next thing we need to do is create a do block to capture any errors. Let data equals try data content of file URL. And that just reads the data from the file. And then let decoder equals JSON decoder. So create a new instance of the JSON decoder. Loaded products equals try decoder decode and then product.sell. So what that means is that we want to decode the JSON payload as an array. That's what that means, the brackets. To decode it as an array. And also the decoder will be expecting an array of JSON from data. So it passes the JSON data into an array of product objects. And then we need to catch the error, and then just like display a little error message on the console. JSON data, and display the actual error. And then what we're doing now is return the array to the user. Let's see if this compiles. So there's an error there on line 25. There's a spelling mistake. That should be contents of and not content. So you need an S at the end of content. There should be an S there. Let's compile it now. Oh, there's another error because we need to create our bar chart view. So let's just create a blank bar chart view. So that's a SwiftUI file. So just go into the project, click on new file, select SwiftUI, and then add the name of the file, which is called bar chart view. And now this won't be complaining because it's expecting a bar chart view and not a content view. So let's compile it now. Oh, there's still an error somewhere. Data, let data equals try data, contents of, contents should be a small c. So that should be a small c. Compile it again. Yeah, good, that compiles. And remember, this is what we're aiming for. So as you can see, home decor, food, clothing and electronics, sports and books. All of that data is coming from the JSON file. As you can see, 15,200, that's home decor. 5,000 is food. And books is 500. So that's what we're aiming to do. And then the next thing we need to do is we need to create you're just thinking what else we need to create. Yeah, we need to create our bar chart view model class, our SwiftUI file. So what we'll do, we'll create a brand new file again. So hold down the control key, CTRL, and then left click on the mouse, select new file, select SwiftUI, click on next. Enter the name, which is called bar chart view model. Click on create. And then we don't need the preview. And for the view, we don't need that view. So just rename that to observable objects. And the purpose of the bar chart view model is to manage the data and logic for the view. And let's delete lines 11 to 13. And then create another variable called @published. @published bar products product. And the purpose of the @published products variable is that it will create an array or hold an array of products. And also with struct we need to rename that as class. And then the next thing we need to do is create an initializer which is called init, and create a method called fetch products, private function fetch products, and then type in products equals data. So read JSON data. So what that will do, it will read all of the JSON product data into the products array, which is in here. Oh yeah, that should be data manager. As we are calling the static variable that we created earlier, which is here, the static variable, I'll just go to the definition, which is here, static function, read JSON data. And then to initialize the function to be called, we just type in fetch products. So as soon as the bar chart view model instance is created, it will call this initializer. Here, this is the initializer. The initializer has one function that will be called, that's called fetch products. That will then contain an array of products by calling read JSON data method from the data manager class. So the next thing we need to do for the view model is have a function called function getHeight. And the purpose of the getHeight function is to calculate the height of each of the bars within the bar chart, and also to set the maximum height to each bar. So that's what we're going to do now. GetHeight for value int max value int returns a CG float data type. Let max height CG float is equal to 200 pixels. Let percentage is equal to CG float value. And then what else do we need to do? Return percentage times by max height. I've forgotten something else on line 24. We need to calculate the percentage, we need to divide it by the max value. So what we do there is type in CG float max value. So what this function really does is that it calculates and returns the bar height. So let's compile it now. It compiles. And then the next thing we need to do is do the actual bar chart view functionality. So the bar chart view functionality is, or the actual bar chart view is this. And that's what we'll do next week. Bar chart screen and functionality to show the bar labels and the totals for each bar, and to retrieve the JSON payload to populate the bar chart data. So that's what we'll be doing in this tutorial. Within your bar chart view, enter the following after line 10. At state object private bar view model equals bar chart view model. So what that line is doing is creating an instance of the bar chart view model to manage the data and logic which is in the actual view model for that bar chart. And the reason for having the view model is just to separate the logic from the actual view, which we have in the view model instead of the actual view. Just like encapsulation. On line 14, we need to create a VStack. So just enter VStack. And then on line 17, we can just cut the text and put it on line 15. And then change the name of the text from Hello World to Orders. And then we style the font for the orders with a system size 30, and then the weight, just make the screen a little bit larger. The weight, dot bold, design default dot foreground color black, and then we will be using a geometry reader, and the purpose of that, it checks the available space. So just enter geometry reader or select it from the drop down. Geometry, I'll just change this and remove the word reader in. So this is a completion handler or closure, and just type in scroll view dot horizontal show indicators is true. So the purpose of having the scroll view as horizontal is so that we can scroll the actual bar chart from left to right. So if the bar chart contains like 50 bars, we can view it on the screen by scrolling from left to right. And then the next thing we need to do is, we need to create a H stack. And the purpose of the H stack is to arrange the bars and the labels. So just type in H stack alignment dot bottom spacing dot 0 spacer. This is the initial spacer, and then just type in let max value is equal to view model products dot map $0 order count dot max. So what that line does, it calculates the maximum order count for scaling. So if the maximum order count was, for example, 1000, it makes sure that that's the highest maximum of the bar. And then the next thing we need to do is loop through the products to create the bars. So we have to use a for each loop for that. Just type in for each view model products sorted by $0 order count is more than $1 order count. Yeah, there's a mistake there. So where it's got sorted by, after the colon, we need to add one of these brackets. We need to add one of these brackets there. And we need to add a closing bracket, which is there. And then we need to add a comma here, ID, product ID, bracket, curly brackets, order in. So let me just compile it just to make sure. It compiles. So what that line does, it loops through the sorted products to create the bars. The next thing we need to do is create a V-stack. And this V-stack will contain the bars and the labels. And then we create a Z-stack. Alignment dot top so this alignment dot top, and then we need to use the rectangle modifier. Just type in rectangle. Dot fill. Fill the color blue. And then type in, next thing we need to type in and just checking to see what else we need to type in for that. So that will fill each of the bar charts with a blue color. Dot frame width 30, height, get height, width 30, height, view model, get height, and then we just pass in order dot order count. And then for the max value, we use the maximum value of the orders that we created earlier on line 26. So we just type in max order, max value. And then for the corner radius, we just make the bars have a corner radius of 8 so that the corners are a little bit smooth, it doesn't have an edge. Dot shadow, color, gray, radius 2, x 0, and y 2. So the next thing we need to do is display the order count on the top of the bar. So each of the orders will be like displayed horizontally. So just type in text, order, the order count, and order the order count. This is the key value that is retrieved from the JSON that we done a few days ago. That's the order count, that's the property of the JSON, that's the key, and 2000 is the value. So we get the order count, and then we will just style the order count, dot caption, dot foreground color, dot black, dot alignment, alignment guide, dot top, D in D open bracket bottom. And it should be D, not do. And the offset will be Y -1. It's offset for better alignment for the order count label. And then the next thing we need to do is to display the product type labels vertically. So we're going to use a geometry reader again. Inner geometry and in. Give it a spacer so there's a bit of space between the bottom of each of the bars and the labels. Text order dot product type dot font dot caption dot font dot foreground color dot black dot rotation effect degrees dot degrees. So just give it 90 degrees. Dot frame. Width. Inner. Geometry. Dot size. Dot height. Height. Inner. Geometry. Dot size. Dot width. Dot fixed size. Dot offset. X minus open bracket inner geometry dot size dot height minus inner geometry dot size dot width. And then we divide it by 2. And then next thing we need to do is, I think there's something missed out again. Open bracket geometry. There's too many spaces there. Dot offset Y 20. And then give the labels some more space. Say centered correctly. And then what we need to do is set the frame height to 100. And this will also set the height for each of the rotated labels for the product type. So each of the product type labels will be 100 pixels in height. And then so what else do we need to do after that? Yeah, we have to give it some more spacing on line 67. And then on line 69, just type in dot frame, dot width, geometry, dot size, dot width. So what that does, it just matches the width of the available space using the geometry reader, so there's not too many gaps on the view. so that each space is equally filled as much as possible. And then, oh yeah, it should be size, not sizes. So just take away the S. And then on line 72, we just add a frame with a max height to 300. And the purpose of that is to limit the height of the scroll view and the content of the scroll view. So what we need to do now is to display the total number of orders. For example, the total number of orders is all of this in the JSON file. So 2,000, 4,000, 15,000, 200, 5,000, 1,000, and then 500. All of these totals will be like summed, and then that sum will be shown on the bar chart view as the final total. So let's do that now. So just type in let total orders is equal to view model.products compact map percent dollar order count. No, that should be order count. Reduce zero and then plus. So what that line does, it will just calculate the actual order count values within a loop, because this is similar to a loop, like using a for each or for loop. You calculate it, but it does it in one line using compact map. And now we've got the total of the orders. We want to display it, so create another text, and the label is total orders dot font dot caption dot foreground color dot gray dot padding dot top dot 16. And what that does is that it adds padding above the total orders text. And then the next thing we need to do is add a bit of padding on line 82 dot padding 16. And the purpose of that is to apply padding around the whole VStack content. And then we need to also apply some styling to the background with a shadow effect. So just type in dot background, rectangle or rounded rectangle, corner radius 10, dot fill, color dot white, dot shadow, color dot gray, dot opacity 0.3, radius 10, x 0, y 2. And then on lines 89, we need to create an overlay, which is a stroke around the view for visual effects. It's not important, just to make it more visually. Dot overlay rounded. Just move it in there a bit. Rounded rectangle, corner radius 10, dot stroke color gray, opacity 0.5, line width 1, and then we need to set the frame min height. Dot frame min height 300. So that sets the minimum height for the view. Dot padding dot bottom 116, and what that does, it adds padding at the bottom of the view with a 116 spacing. So now we try to run it. Should work, so let's try to run it now. My Mac is a bit slow, so it takes about 30 seconds most times to load up, to compile and run. Oh, where's the graph? It didn't display it. It's not displaying the data. Let's see if it's getting the right file from the data manager class. Customer orders. Oh, that must be the reason. Within the data manager class, on line 22, the file name has customer order, but there should be an S at the end. So it should be customer orders. So that it's similar, so that it's exactly the same as the customer orders JSON file. Because it couldn't find a JSON file, that's why it didn't load the JSON. So let's try it again and see if it works this time. Yeah, it works. So you can see all the information is populated from the JSON, which is here. So if I put that here, it makes it easier for you to see. Just move it over here. So you can, I'll lift it up a bit. As you can see, 2,000 electronics, 4,000 clothing. So if clothing was £50, it'll be updated. So just change it to 50. It's just loaded at the moment. So you see £50 for clothes. Here's 50. Clothing, £50. So you can see that the bar chart has been uploaded and it's using updated and it's using populated data from the JSON file. And if you want to see a pie chart example, please submit a comment to let me know. Then I'll create a pie chart example using JSON data. In this tutorial, we will be populating a pie chart using JSON data in SwiftUI. So this is the pie chart we'll be creating, and all of the actual information comes from a JSON file, a JSON array. As you can see, it contains about 10 different orders or products. So this is what we will be doing in the tutorial. So this is the JSON data that we will be using in this tutorial. The JSON data includes an array of objects. These are the keys. Order count is the key, and this is the value, which is 2,000. And also product type is the key, and electronics is the value. So it's the key value pair. So the first thing you need to do is to create this JSON file. And how you do it, you have to hold down Control key and then left click on the mouse and then select New File. And then you navigate to the empty file. So you click on it and then you just give it a name. I'll just call it customer orders 1.json, but you call yours customer orders. So I'm just calling it customer orders 1 because customer orders.json already exists. So I just create it and I'll be deleting it afterwards. As you can see, there's a JSON file, customer orders 1 and customer orders. So because customer orders already exists, we will delete customer orders 1 because customer orders 1 isn't needed. So to delete it, just click on backspace and then select move to trash. So this is the actual JSON you have to type in manually into customer orders.json file. The next thing we have to do is to create a class called Data Manager. So to do that, just click on Control key and then left click on the mouse button, on the mouse pad, and then click on New File. Select SwiftUI as the file. And then for the class name, for the file name, just enter Data Manager. Click on Create. Next thing we need to do is type the following, which is struct product codable let product type string, let order count int. So product type is a codable object, and the reason why it's codable is because we will be mapping the actual JSON structure to our codable product class. And as you can see, the codable product class, it includes the same attributes as our JSON. So if I go back into the JSON, you'll see it has the same attributes, order count and product type. I just copy it, then you can compare it on the next screen. So if I just place it here, you can see it has the same attributes, order counts, which is there, and product type, which is there, and the data type for product type is string, which is this one here, home decor, and order count is int data type. The next thing we need to do is to create our class, which is public class data manager. And then we create a static function called static function read JSON data that returns an array of product. So it returns a list of products. Then create a variable var loaded products. Product equals open bracket, close bracket. So that creates an empty object array of product. Next thing we need to do is to check that the JSON file exists in the project bundle. So what we do is type in the following: if let file URL. So we're doing safe unwrapping equals bundle main.url for resource. And then we enter the name of the file, our JSON file, which is called customer orders, which is the same file here on the left-hand pane. And the extension is JSON. And then if any errors happen, we need to capture those errors using a do statement, and also have the catch statement. So what we do here is type in let data equals try data contents of file URL. So what that does, it just reads the data from the file using this URL. So we're passing this URL, this file URL, to the contents of the data object. So it's just passing it to the constructor or the initializer of the data object. Let decoder equals JSON decoder. So that just creates a new instance of the JSON decoder so that we can use it when we're decoding the JSON into our array. Loaded products equals try decoder decode product dot sell from data. And so what this means, line 27, is that the decode method will be expecting an array of JSON. That's why there's brackets around the product. That's why they do these brackets. That means it's expecting a JSON payload. If it didn't have the brackets, if it had this, as in no brackets, that means it's expecting a dictionary. But because we're like using arrays of JSON, we need to include the brackets so that the information will be decoded or received correctly, as in pass. And just display any error, just in case any errors happen. So you can just type in error loading JSON data and then just put error there, so it would just display the error to the console, just for testing purposes. And now the next thing we need to do is to return the result back to the caller or back to the routine that's waiting for the method to finish. Return loaded products. Now let's compile it to make sure it's correct. Still compiling. It's compiled. So now the next thing we need to do is to create a pie chart view model. So to do that, we need to create a SwiftUI or import SwiftUI. So we have to create another file. So just click on Control and then New File, and then select Swift File. Call the new file, name the new file pie chart view model. And then next we need to import SwiftUI. And then create our class pie chart view model observable object, and then the purpose of using observable object is to listen for changes that will be happening, and then we have to create another variable which is a publish object. So at publish bar product, and the purpose of the publish object is to publish as to notify the application of any changes that's happened, and then on the UI will be refreshed with the updates from the publish using observable. Now we have to create an initializer in it, and the next thing we need to do is to create a function to fetch all the products from the JSON file. So let's call that func fetch products. And then within the initializer, we type in fetch products. And it's spelled incorrectly, so it should be D-U-C at the end. D-U-C. And then we have to assign the fetch products to our products array. So how we do that? We just type in products, data manager dot read JSON data. So as soon as the read JSON data method is called, the data will then be inserted into products, into the products array. So the next thing we need to do, we need to create a function that will generate or create an array of slices for the pie chart. And that function will create and display the actual order count and the actual slice value. So to do that, we need to type in the following function, func create slices slice. So the create slices function returns an array of slices. And the next thing we need to do is calculate the total order count by summing the order counts from the products. And how we do that, we type in the following: let total order count equals products map $0 order count reduce $0 plus. So what that does, it's a little bit like using the for loop. It does all the concatenation and then it calculates the actual sum. That will be a single value for the actual order count. Yeah, because slice doesn't exist, we haven't created that object as yet. That's why there's an error, but we'll create that later. The next thing we need to do is create an array to store the slices and the percentages. So what we do, we just create a new variable, var slices, slice. So that creates an empty array, var total double equals 0.0. And now we need to loop through the products to create the slices. So just type in for index product in product enumerated let value equals double product order count. So what that's doing is it's getting the order count for the current product, and then we need to the next thing we need to do is to calculate the percentage of the product and the order count that's related to the total. So how we do that, we have to create another variable, let percentage equals total order count is not equal to 0 or value double total order count. On line 26 there's an error, there shouldn't be an S at the end of order counts, so let's delete the S there. So total order count times by 100. And we need a space after the equals. And let's see if there's any more errors. We need to pull this in a bit. And then we need a colon here, 0. And then the next thing we need to do is to calculate the start and the end angles for the slice. So we need to type in the following. Let start angle equals slices last end angle Yeah, because we haven't created the slice object as yet, end angle is not available, but we'll be doing that later. Question mark, dot, degrees, 0. Next thing we need to do is to calculate the end angle. End angle equals start angle plus dot degrees percentage times by 3.6. And then next thing we need to do is create a get color function. And the purpose of the get color function is to color each of the slices based on their index. So to do that, we need to navigate down to line 41 and create a new function. It's called func get color. Index int returns a color. Let colors color equals dot red, green, dot blue, dot orange, dot yellow, dot purple, dot brown. So what that does, it defines an array of color objects. And then the next thing we need to do is to calculate the remainder of the index divided by the number of colors in the array. So how we do that is we type the following: let wrap index equals index modular sign colors dot count. And then no, that's incorrect. It should be colors dot count. And next thing we need to do is to return the color at the calculated index, the calculated wrap index. So just type in return colors wrap index. So now the get color function that's now done. So now we return back to lines 38. And now you can get the actual color from the get color array. So just type in let color equals get color index. So what that will do, it will get a color for the slice based on the index. So if the index was 0, it will get red. If the index was 1, it will get green. If the index was 2, it will get blue. And next thing we need to do is to create another variable called slice equals slice. So at the moment we don't have our slice class, but we can type in the values. Value, value, color, 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 start, angle, start, angle, end, angle, end, angle, total, double, total, order count. So when the slice object has been created, it will be passing these parameters to the constructor, to the initializer. Next thing we need to do is to update the percentage for the actual slice of the pie chart. So how we do that, we just do concatenation on the total. So just type in total plus equals percentage. And then we add the new slice that we created to the slices array. Yeah, so there are a few compile time errors because, as I said before, we don't have the slice object or class at the moment. So next week we will create the slice object. So at the moment this is what the code looks like, and also the data manager class, the content view, we haven't started on that yet. Today we will be focusing on the following functionality, which is the slices within the pie chart, and also the actual pie chart, the actual circle within the pie chart. That's a functionality that we'll be creating today. Within your Xcode project, add a new file and call it slice. And this is a strut. So just click on the control key and then left click on the mouse. and then select Swift file. Give the file a name, which is slice, and then click on create button. Next thing we need to do is to create our strut. So just type in strut slice identifiable. The purpose of using identifiable is so that the actual strut can be looped through within an array, and it also generates a unique ID for each record in that strut. Type in let ID equals UUID, and the UUID, unique identifier, that generates the unique ID for each of the slices. Let value double, and the purpose of that property is to store the value of each of the slices. For example, if the value of the slice was like 20%, let color let start angle is angle, we also need to import SwiftUI, forgotten about that. Import SwiftUI. Let end angle, which is angle. So the start angle is the starting position of the slice, and the end angle is the ending position of the slice in radians. Let total double. Next thing we need to do is to create a property, and the purpose of this property is to retrieve the total slice total of all the slices in the actual pie chart, and then it calculates and returns a percentage. Return value divided by total times by 100. So this is a computed property that calculates the percentage of the slices that relates to the total. I'll just compile it. There will be one or two errors. This is what we done last week, so it's something to do with a label. So it's on line 41. So we need to replace color with color. So just click on fix. And now the parameters have been updated, and then there should be a return that returns a slice object. So we need to go back into the pie chart view model, and then after line 46, so outside of the loop, just type in the following slices. Now let's compile to see that there's no errors. Now the next thing we need to do is to create our pie chart view. And the purpose of the pie chart view is to display the actual pie chart, the circle that includes the slices. So let's create our SwiftUI pie chart view. So click on the control key and then click on new file. Select SwiftUI view as the file type and give the new file a name which is called pie chart. And then the next thing we need to do is, after line 10, we need to declare a few properties which are let slices slice. So this is a slice array, an array of slices. Let center equals G point, CG point. Let radius equals, colon, semicolon, CG floats. And then we can delete the lines between 20 and 24. And the next thing we need to do is we need to create another function. And the purpose of this function will be to calculate and to display the text within each of the slice within the pie chart. So we just create a private function which is private func calc text position slice slice. So the function accepts a slice object and returns a CG point and the purpose of returning a CG point is because within the pie chart sometimes the numbers doesn't have a big enough space to display the actual number within that little slice, so it has to make sure that the space is big enough by sometimes altering or rotating the numerical slice value of the percentage within the actual slice. And that's why the function is called calculate text position or calc text position. Next thing we need to do is to create another variable. It's let angle equals slice start angle radians plus slice end angle radians divided by 2. So the purpose of that is to calculate the average angle between the start and the end angle of each of the slices. let x equals center dot x plus open bracket radius divided by 2 times by CG float cos angle. And the purpose of that line is to calculate the x coordinates for the text position based on the angle and the radius. Let y equals center plus radius divided by 2 times by c g float sin angle. The purpose of that line is to calculate the y coordinates for the text position based on the angle and the radius. And now what we need to do is to return the CG point. So just type in return CG point x and then y. And what that does, it returns a CG point that represents the calculated text position. So let's just compile it. Just compiling at the moment. The Mac is a little bit slow. Yeah, the Mac is really slow. That's why I don't really use my previews on video, because the Mac is so slow when compiling. Still compiling. Oh, there's an error somewhere. So the error is to do with CG float. Let dot x equals center dot x plus radius divided by 2 times by CG float cos angle. CG. Oh, what it is, yeah, made a mistake. On line 13, the data type should be CG float, as it mentions here. The radiance should be CG float. So on line 13, we just rename the data type to CG float. Now, if I compile it, it should compile. But it doesn't mean that it's correct, but it should compile. So that compiles. So the next thing we need to do is, within the body on line 16, delete line 16 and then enter the following. We need to create a Z stack. Now create a for each. Slices slice in. And the purpose of this is to loop through all the slices to create a pie chart segment. And then we need to type the following: path in path dot move to center, path dot add arc, center, radius, passing radius, start angle, slice dot start angle, end angle, slice dot end angle, clockwise, force, so it's anti-clockwise. So what that does, it creates a path representing a segment of the pie chart. Next thing we need to do is call the fill method. Fill, open bracket, slice, color. And the purpose of that is to fill the path with the color of the slice. So if the color of the slice is blue, then the slice will be blue. Or if it's grey, it will be grey. And then next thing we need to do is to create an overlay. And the purpose of the overlay is to overlay the slice percentages text on the segment on the pie chart. So you just create an overlay and then type text, then int slice percentage, so this is where we display the actual percentage of the pie chart slices. Dot font, dot caption, dot font weight, dot bold, dot foreground color, black, dot position, dot position, calculate text position, and then pass in the slice. And then let's compile it just to see if it compiles. Compiles, which is good. So the next thing we need to do is to create the actual pie chart view to display the actual pie charts and the legend and the slices, so to display everything onto the pie chart view so that the user can use the actual pie chart and see it. So that part we'll be doing next week. in the final tutorial of the pie chart. Full pie chart tutorial. In the content view, type the following: at observe object private var view model equals pie chart view model. And then delete line 16 to 18. And then on line 17, type orders and this will be the headline for the pie chart. Then type font, headline, geometry reader, geometry in. And the purpose of using the geometry reader is to adapt to the available space for the pie chart view. Next, type in hstack spacing 50. Next thing we need to do is to create a VStack, alignment, dot leading, spacing 8. And the purpose of this VStack, it will hold the legend for the pie chart. The next thing we need to do is to loop through the products and looping through the products that will create the actual legend data. So just type in for each view model products indices ID self index in. Next, create a hstack, and then within the hstack we need to display a small circle filled with a color based on the product index, and this is still for the legend. Circle dot fill view model get color index dot frame width 12 height 12, and then we need to display the product type, and this is still within the legend. Text view model products index dot product type. And then the next thing we need to do, after line 32, add some padding, background color, which is white, dot corner radius, which is 8, dot frame, the width is 150, dot shadow, color, I think there's a mistake, let's do that part again, dot shadow, let's just come up with color, a color, color, dot grey, opacity 0.3, comma, radius 10, x is 0, and y is 2. And then the next thing we need to do is to check if the viewModel product array contains any data. So we have to make sure that the array isn't empty. So we need to do the following. If not viewModel products is empty, pie chart viewModel dot create slices, and then center CG point, open bracket, X, geometry, dot size, dot width, times by 0.5, minus 120, and then I think there's a mistake somewhere. After 120, we need to use the y parameter. So it's y geometry dot size dot height times by 0.5. And what that line does, line 41, it sets the center of the pie chart. And then we need a comma after the last closing bracket. And then we need to type in radius, min, geometry, size, I think there's an error there. Geometry, size, dot width, geometry, size, dot height, times by 0.35. And the purpose of line 42 is to set the radius of the pie chart. And then we just add our closing bracket on line 43. So it closes the pie chart. It's the opening bracket. And this is the closing bracket for this block. And then the next thing we need to do is after line 46, type dot frame, max height 300. Let total orders equals view model products dot compact map $0 order count dot reduce 0 plus and the purpose of line 49 is to calculate and display the total order count. So line 49, similar to a loop, but we use compact map and reduce to calculate the values, to add up the values in the array. Text, total orders dot font dot caption dot foreground color dot gray dot padding top 16 and on line 55 the padding should also be 16 there. Dot background rounded rectangle, corner radius 10, dot fill color, dot fill color dot white dot shadow color gray, opacity 0.3, radius 10, x is 0 and y is 2. And then on line 61, just type in dot overlay, open bracket, rounded rectangle, corner radius 10, dot stroke color dot gray, opacity 0.5, line width 1, and then type in dot frame, min height 300, dot padding dot bottom 116, dot on a pair and then we call view model dot fetch products, and this will populate our pie chart with the data. Yeah, so let's run it and see if it works. It's compiling at the moment. Still compiling. Oh yeah, so now it's running. So that's the pie chart with the data and the legend. So if we wanted to, we can change the values of the pie chart. We can change the textual information, like the products, the orders, or the numerical values. To do that, we just go back into the JSON file, which is customer orders. So if we want to change electronics, we can just change it to something else. So just go into customer orders and just change it to pets, and just set a price for the pet, say about £400. And then when I run it, the pie chart will be updated with the new value of pets for the product type, and the price of the pet, or all the pets, are £400 in total. Just compiling at the moment. As you can see, pets, it's been updated. Next week, I'll be creating a line chart with dynamic animation for the line. So remember to comment, like, and subscribe to not miss out on next week's video. We will create a line graph to show the product purchases over time. The graph is populated using JSON data. And here is the graph as displayed on the screen. It has data points. Clicking on a data point shows the price that relates to that data point. For example, that's 2000, and the 2000 is just a little bit underneath the 2080, and this is 4000, and that's a little bit underneath the 4160. And this product is 2500, and this is the cheapest product. This is the cheapest product price, which is 550. It's just a little bit below the 1000. So this is the application that we are creating in this tutorial using SwiftUI. The first thing we need to do is to create our JSON array of objects. So this is the JSON array of objects. It includes 1, 2, 3, 4, 5, 6, 7, 8 objects. And each of the objects includes one key value or attribute. This is the key, which is order count, and this is the value, 2000. And this is the other object instance, order count, and that's the key for it, 4000. So the order count attribute is like the price, or you can name it anything really. So that's the first thing we need to create, and to create that, you just hold down the control key, and then left click on the mouse, select new file, and then scroll down to, I think it's blank file or empty file. Select empty file, and then just click on next, and then you just give it the name customer orders. So I just do one here, but I'll call it a different name because I don't want to replace the original customer orders file. So I just call it abc.json. Click on create. As you can see, it created an empty file. So this empty file, abc.json, .json should have the actual JSON payload. So this is the JSON payload that you include within your customer orders.json file. I'll just delete the ABC file now because we're not using that one. Move to trash. So this is the information that you need to enter within your customer orders.json file. And you can also see it here on the right hand pane, the far right. This is the file, custom orders.json. Having created our customer orders.json file, the next thing we need to do is create our data manager class. And the purpose of the data manager class is to retrieve the JSON payload and populate the graph later. So to create the data manager class, hold down the control key and then right click on the mouse button. Left click on the mouse button and select new file. Select Swift file. Click next. Give the file name the name of data manager. And this is also the name of the class as well. So I'll just copy it. Click on create. And then import SwiftUI. Next thing we need to do is to create our codable structs. So the name of the struct will be called product, because we'll be retrieving a list of products. Codable and equatable. And then the key that we're retrieving is order count, which is this key here, order count. So that property or attribute needs to be in the product struct. So we just type in let order count, which is an int. And then now we create our actual class, our data manager class. Public class data manager. And then the data manager class will have one property, one function. Let's use a function. It will have one function which is a static function. So just type in static func read JSON data. That will return an array of products. Var loaded products. Product equals open bracket, close bracket. So what that does, it creates a product variable called loaded products that will include an array of objects of type product. If let file URL equals to bundle main.url for resource customer orders, so we're getting the actual data from the customer orders JSON file with the extension JSON, and here on line 21 we're doing safe unwrapping. So if the file exists, then it will do this code block section that we're going to create now, else it will display an error message in the catch block. So now we just have to do the do block to capture any errors as well, and then the catch block is afterwards, and we just type in a little message to display any errors that was captured. Error loading JSON data, and then display the error that happened. And then within the do block we will try to execute the instructions. So just type in let data equals try data contents of file URL. What that does, it reads the data from the file. So it's passing the file URL, which is this, customer orders.json, which is located here or here. As in here, this is where it's located. So it's passing that location to the data constructor, and then if it exists it puts the return values, which is the data payload, into the data variable, which is an array. Next thing we need to do is to create a decoder. So just type in let decoder equals JSON decoder. Loaded products equals try decode. A decoder, spelled it wrong, there shouldn't be no R there. Decoder decodes. And then we assign the product codable struct and type in self, because we're retrieving an array from data. So what that line does, it passes the JSON data into an array of product objects. And then the next thing we need to do is to return the JSON payload to the caller or to the function that's waiting. So on line 30, just type in return loaded products. Let's compile it now, just to make sure that it compiles. Just compiling at the moment. It compiles. So the next thing we need to do is to create our view model. And the purpose of the view model will be to fetch the products. So to create our view model, we just create another class. Hold down the control key and then left click on the mouse, click on new file. And then for the file name, just enter line graph view model. Click on create. Import SwiftUI. And now we create our class. So just type in class line graph view model observable object. And the purpose of the observable object is to enable the class to observe all the attributes and functions of any changes that has happened. And then if any changes has happened in the attributes or functions, then we use a publish object to publish the changes to the user interface, the GUI. So this is how we do it. Just type in publish var products and then just type in product, which is an array of products. The next thing we need to do is to create an initializer. So as soon as we create an instance of the line graph view model, the initializer will then be called and then call the actual function within that initializer. So let's create that function now. Func fetch products. Products equals data manager dot read JSON data. And then within the initializer, the init method, we just call fetch products. So as soon as the instance is created, as soon as this instance is created, line graph view model, this will be called, and then calling this calls this, and then because we call the fetch products function, that means the read JSON data function within the data manager class is called, and then all the data is then assigned to the products publish variable that includes an array of products. So let's compile it just to make sure that it compiles. It compiles. So yeah, next week we'll be doing the line graph view. The line graph view. The purpose of the line graph view is to create horizontal and vertical lines and to add data points to the line graph. So within your projects from last week, create a new file, Swift file, and name it line graph. So you just click on the control key and then left click on the mouse, click on new file, Swift file, that means SwiftUI file, click on next and then enter the name line graph. And then after line 10, enter the following: let data points product. So the purpose of the data points products array is to have an array of data points that includes the JSON array from the file, which is order count, that has the key value. Let graph width CG float. Let graph height CG float. And then we need to create our state variables. At state private var path completion CG float is equal to 0.0. And the purpose of the at state path completion variable is to control the drawing of the line from 0 to 100%. It's used within animation, so it goes from 0 to 100% in a slow way. At state private var selected data point product with nil. And the purpose of that variable selected data point is that it enables the user to select a data point on the line graph, and then when they select that data point, the data point on the line graph will display the actual value of that data point. For example, I think the previous one is still on the screen. I think if we click on that one, for example, there's a data point and it shows 5,000. The next thing we need to do is to create a geometry reader. That's on line 20. So just type in geometry reader geo in. Let width equals geo dot size dot width. Let height equals geo dot size dot height. Let x scale CG float equals width divided by CG floats data points dot count -1. And the purpose of that line 25, is that it calculates the scaling factor for the x-axis by dividing the width by the number of data points. Let y scale CG float equals height divided by CG float data points dot map $0 dot order count dot max question mark 1. And what that line does is similar to the previous one, but this line, it calculates the scaling factor for the y-axis by dividing the height by the maximum order count. Or 1 if there's no data point. That's the optional. And what else? I missed out something. It's a bracket. Order count. Equals height divided by CG float. Oh, that should be CG float. Next thing we need to do is to create a Z stack. And now we need to loop through the range of values to create the horizontal grid lines. So what we need to do is to create a for each loop for each 0 dot dot less than 6 ID self I in let y equals height minus CG float open bracket I close bracket times by height divided by 5.0. And what that line does, it calculates the vertical position for y for the current horizontal grid line. Next thing we need to do is to create a path for the horizontal grid line. So just type in path. This is another closure. Path dot move to CG point X 0 Y Y. So what that does is it moves to the starting point of the line. Oh yeah, we need in on line 35, so that should be path in. Path dot add line CG point open bracket X colon width Y. And the purpose of that line is to add a line segment to the ending point of the line. The preview, we can delete it because we're not using it. And then after line 38, just add dot stroke open bracket color dot white dot opacity 0.5 line width 0.5. And what that line does, it sets the horizontal line color to white with opacity of 0.5. And then the next thing we need to do is to display the label text for the current horizontal grid line. So to do that, we're going to use text. So type in text, open bracket, comma, I times, open bracket, data point, dot map, $0, point order count, dot max, question mark, 1, and then we need to divide by 5. Dot font, dot caption, dot foreground color, white, dot position, CG point -20, and then Y. So what that does, it sets the label text color to white, and then it positions the label to the left of the grid line. Now, the next thing we need to do is to loop through the chart to create the grid lines, to create vertical grid lines. So to do that, we need to create another for each loop, similar to what we've done previously. So for each zero dot dot is less than data points dot count ID self I in let x equals CG float open bracket I times by x scale. And then we need to create a vertical path for the grid line. So that's path in path.move to CG point x y 0. And the purpose of that line is to move to the starting point of the line at the bottom. And then we have to create another path dot add line to CG point x y height. And the purpose of that line is to add a line segment to the ending point of the line at the top. Dot stroke color white, opacity 0.5, line width 0.5, and the purpose of that is to set the vertical line color to white with opacity of 0.5. And then we have to create another path. And this path will be for the data points. So after line 55, enter the following path in for index product in data points enumerated let x equals CG float open bracket index times by x scale So the purpose of that line is to calculate the horizontal position of x for the current data point. And then we have to do something similar for y as well. Let y equals height minus CG float product order count times by y scale. And that line calculates the vertical position of y for the current data point. If index is equal to 0, path.move to CG point x and y. So what that does, it moves to the starting point for the line if it's the first data point. If it's the first data point, that means the index is at 0. But if it's not the first data point, then it will do this within an else statement. Path.addLine to CG point x y and then close bracket. And then now the next thing we need to do is we have to trim the path from the start of position 0.0 to the current value for the path completion to create the animation effect. So when the line graph line is moving from 0.0 to the destination, so to do that we need to do it online. After line 69, so what we need to do is just type in .trim from 0.0 to path completion. Stroke black line width 2 on a pair with animation dot ease in out duration 2.0. Path completion equals 1.0. So what that line does, it animates the path completion property from 0.0 to 1.0 with an ease in, ease out effect over 2 seconds. And then the next thing we need to do is, after line 79, to type the following: .drawing group. And the purpose of .drawing group, it just improves the rendering performance when doing dynamic drawings. For each data points, indices ID, self index in, let products equals data points index. So what that line does, it just gets the current product from the data points array by using the index on this line. Next thing we need to do is to calculate the horizontal position x for the current data point. So we just type in let x equals cg float open bracket index times x scale, and let y equals height minus cg float and that should be cg float open bracket product dot order count times by y scale. And what that does, it calculates the vertical position of y for the current data point based on the order count and scaling factor. So the next thing we need to do is to create buttons, like add buttons to the data point, so that when the user clicks on the data points, it will be like a button event, so that the actual data point value is displayed by clicking on it. So what we need to do is to create a button, so that's button action selected data point equals product and then we need a circle dot fill dot white dot frame width selected data point equals product question mark 50 colon 8. Height selected data point equals product question mark 50 colon 8. So what that line does, those two lines, it creates the height and the width of the clickable data points for the button. And then the next thing we need to do is to create an overlay. So just type in dot overlay. Text, open bracket, selected data point equals product question mark product dot order count colon comma. And then we need to add a little font style dot font dot caption dot foreground color dot black and then after line 105 just enter dot button style plain button style dot position CG point X and Y. Let's compile it just to see if it compiles or not. Yeah, it compiles. Next week we will add the line graph view that includes the actual interface so that the user can interact with the application, such as clicking on the data points and displaying the full graph. Line graph to the view so that the user is able to interact with the GUI, such as pressing on the circles for the data points. So this is what we'll be doing in this session, and that will complete the line graph tutorial. Within your Xcode project, rename the content view and call it line graph view. Also rename it here as well, or we can refactor it. To refactor, just highlight the struct name and then click on Control key, CTRL, and then click on refactor and then click on rename. Enter the name, which is line graph view, and then click on enter. And that name should be also renamed automatically within the line graph app file, and it has been renamed. So the first thing we need to do is to create an observed object. So on line 11, just type at observed object private bar view model equal to line graph view model. And then on lines 13, within the vstat, just delete everything between line 14 and 17. Also delete line 16 as well, the padding. And then within the vstat, just type in this title, text, sum of orders over time. That's the heading for the line graph. Dot font title. Dot foreground color. Green. Dot padding. Dot top 16. So what that will do, it will position the text 16 pixels from the top. Next thing to do is to create a geometry reader. So it's geometry reader, geometry in, and then we have to check to make sure our view model contains data. So just type in if not view model products array is empty. If it's not empty, so if there's data in the array, let scale factor CG float equals 0.75. So what that does, that variable scale factor, it will make the graph 25% smaller so that it fits on normal screens correctly. So the next thing we need to do is type in let scale width equals geometry dot size dot width times by scale factor. Let scaled height equals 200 times by scale factor. And then we need to create a H stack, horizontal stack, H stack. And then within the H stack, we will center the line graph horizontally. Spacer, line graph, and then for the data points, type in view model dot products. For the graph width, type in scaled width, and then scaled height, so that the width and height will be 75% smaller. 25% smaller. And then the next thing we need to do is set the frame height and width, dot frame width, scaled width, and height, scaled height. And then just type in dot padding, dot top 16. And the purpose of that line is to add padding at the top of the line graph view to create some spacing between the title and the graph. And then we need another spacer. On line 39, add this else statement. And then type in progress view, loading data dot progress view style circular progress view style. And for the tint, let's make it blue, dot blue. And then after line 44, type the following. Let total orders equals view model product compact map order count dot reduce and plus. So what that does, it just calculates the full total of the order count, which are the prices, similar to a loop, but it does it all on one line using reduce and the plus sign. Text total orders total orders dot font headline dot foreground color dot green dot padding dot top. On line 52, enter the following dot padding 16. And then dot background rounded rectangle corner radius. No, that should be corner radius, not corner style. Corner radius 20. And that just increases the corners to have a rounder look. Next thing we need to do is to fill the rounded rectangle background with a linear gradient from blue to purple. So just type in dot fill linear gradient and gradient there as well. And then we're to pass in the colors. Open bracket dot blue, comma, dot purple. For the start point, just make it dot top, endpoint dot bottom. Oh, there's an error somewhere. Dot blue, comma, dot purple. Gradient, linear gradient. Oh, we missed out a bracket, so the bracket should be it's not to do the bracket. So the mistake is on line 54, this closing bracket, which is here, that one here, we need to delete that one and place it anywhere on this line. So the next thing we need to do is to add a shadow to the rounded rectangle background with a grey colour. To do that, just type in dot shadow colour dot grey, or you can do color dot grey if you want to, dot opacity 0.5, radius 10, x 0, comma, and y is 2. And then the next thing we need to do is to overlay the parent view with a rounded rectangle that has rounded corners. So just type in dot overlay rounded rectangle corner radius 20. And then we need to add a stroke border to the rounded rectangle with a grey colour. So to do this, just type in dot stroke colour grey, opacity 0.5, line width 2, the next thing we need to do is to ensure a minimum frame width. So what we need to do is dot frame min. Now we have to ensure a minimum frame height, so it's min height 300 dot padding dot bottom 24. And then we need the onAppear method, which is dot onAppear. And then to populate our chart, to get the data from the JSON file, to populate our chart, we just type in view model dot fetch products. Now let's run it to see if it works or not. Just taking a bit of time to run. It's building now. As you can see, that's our line graph. So if you click on the data points, you can see that this is just a little bit underneath 4,160. So you can include the actual value, and you could also do it so that it includes the value, like the price and the product. For example, if we go back into the JSON file, which is here, you could have a product key down here, so that when you click on the data point, it will say, for example, click on that, it will say 4,000 and the actual product, which is could be like books or TV, televisions, and then you have other data points as well, because they have the same two values, so they come up the same. Because the 2000s, they're in customer orders JSON file, which is here. So that relates to the last data point with 1,000, and this relates to the previous one, which is this one here, and that's the last one. So if you want to, you can improve it so that it's better to include product names as well with the data points, with the values, the product prices underneath. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week.